Hello everyone. So today we're gonna discuss about naive matching as we mentioned in the reverse video. So we have a test here. Yeah, of course we have a test and a product, and it's a zero index. So it means the first index we start from zero. All right. So we have a test here and a product. So to understand the idea of this naive matching, we can imagine that we have a pointer, we call it I here, and we have another pointer that J here. So the I pointer for control the test, the position inside the test, and the J for the point. So we're gonna to compare. We have a test here. So let's call it T for shock and P for shock. So if T I is equal to Pj, so if the first character they are the same, we're gonna move I pointer to the next position. So I will be stay here for the new position, and J as well. We will move J from 0 to 1 here, and we try to compare again. So we repeat the comparison. But now we can see that the second character tests they are different from the point. So they are different. So we call here. So we call it in a matching. So match, and if they are different, we call it mismatch. So we call it mismatch. So what we need to do if a mismatch occur, so if there are a mismatch occur, we need to do two things. So the first thing we need to reset I, and the second thing we need to reset J. All right. So why we need to do the reset I and J? Because you know that if we start from the first position here and we go next, let's say M, len is mean number character of the point. All right, and then equal to number character inside the test. So it means that if we stay here and we go to next M characters, so M character here, if they are matching, so for example, if we stay here, it's a matching. If we stay in the index 6 index and we go next to 4 characters, it means M character, we gonna guess exactly the pattern inside the test. So if they appear mismatch, even though just only one mismatch, we cannot get it. So we stay here because they are mismatch here. We know that. So we sure that if we go from this position, go to next M character, we cannot get the pattern, the P string here. So no, we cannot get the string P. So nowadays we need to compare here. So we see that they are mismatch here. So all right, we have 4 characters. They are mismatch. We know that. So we want to move to the next one more. We want to shift the pattern to now we want to shift to provide one position. So we compare here. So if they are still mismatch, we move on. And so on until we go through every characters inside the test. So when we have mismatch here, we need to preset the G equal to 0. This means that we try to compare again. But I here. So if we have mismatch, for example, I will erase it for more for another discussion. So here, so let's remove it. We call that A, B, C, and A, for example. So we have a margin here, and we have a mismatch here. So we know that this position cannot provide a good matching. So we need to move J to here for new position. All right. So this is our new comparison. So J we will go back to the previous one, but we need to plus one. So let's see, I here, no, sorry, I will be go to O I, but we plus one. All right, that's we need to do. So for convenience, instead of combine J, instead of increase J here, we're gonna change the formula. So we change the formula to I plus J here, I would say. So P J, because you know that I and J, they have a linear relation. So if we use this formula, we only need to increase J. All right. So we don't need to adjust the I value here, just adjust J. So when we reset, so when we need to reset J, we can get still get the OI here, and then we plus one. So it's enough for the next comparison. All right, for the next matching. So that's the idea of the algorithm. So we need for loop here, one loop for the test and one loop for the parting. All right. So we have for I is from 1 to something here. So let's say we go to n, just for assumption now, it's not correct yet, but let's just leave it for a moment. All right. So we have a second for loop J is from sorry, from 0 here. I'm sorry, 0 to m. Yeah, definitely we have no doubt about that. So in here we compare. So if we have test here, okay, so let's say T, so we have I plus J, yeah. If they have a mismatch, yeah, of course, so we P. If they have a mismatch, we rec, because you know that just only one mismatch happen, we cannot get the value. All right, we cannot get a full matching, we cannot get the pattern, so we do not allow any mismatch. All right, so if they are not mismatch, we're gonna increase J to 1 to plus 1. All right, one value. All right, that's it. And then after you is this for loop, so we're gonna check if J here equal to m. It means that we have m matching pairs. So it means m matching pair. So we can return that I is the first occurrence of the pattern inside the test. So if we go through every characters, but we cannot get any full matching, we can conclude that there are no matching, no occurrence of the pattern inside the test. So we return -1 or n. It's up to you. All right. So in here I select the -1 value. How about this one? What value we need here? So you see that in here we have I plus J, but it's the index of the T string. So it means that I plus J must be smaller or equal n-1. Yeah, of course. So we conclude that we have the equalization that n I here will be smaller than equal I minus 1 minus J. But we know that the maximum value J can achieve m-1. Yeah, of course. So we can conclude that y should be equal or smaller than I-1. Yeah. So in here we go to sorry. So we conclude that I should be equal or smaller n minus m. All right. So here we go through n minus m. So that's it. That's our this is the idea of the naive matching. So let's implement it in Python. All right. So let's implement this algorithm in Python now. So we have we need to develop a function here, short function, and we have a parent argument and the test argument. All right. So let's see, we have b length. B length means the length of the parent. So it's equal to parent. Okay. So we have a t length is equal to test. It means the length of the test. How many characters in inside the test. So then we have variable instead of name it as I instead of UI. I call it offset. So it's more contain more meaning. All right. So in range, let's as we discussed before. So we have t length minus b length. But we know that if you want to go to exactly this value, we need to plus 1 in Python. All right. So we have pointer. So instead of name after j, I call it pointer. All right. So we have pointer here. So y pointer is smaller than b length here. So we have if the test value offset, yeah, plus pointer is equal to parent pointer, yeah. So no, not equal. So we have mismatch. So not equal. So it means we have a mismatch here. So let's rec, and then the pointer is plus. We increase pointer to 1. All right, and if we have a pointer equal to p length, so we return the offset, yeah. All right, so right after we go through every characters and we cannot find any matching, any full matching, so we can conclude that the pattern do not occurs inside the test. All right. So let's test the function. So we have a name here, name equal to the main, yeah. And we have a test here. So let's say A, B, B. All right. So assume that and we have a parent. So let so we have A, B. All right. And then we have an offset here. Short, we have a parent, and we have the test. So that's it. And then let's print out the results. So we have a offset here, let's say, and then so that's it. So we know that AAB, so the first occurrences of the pattern will be AA here. So it's 0, 1, and 2. So it should be return number 2. So let's say what happened. So let's test the result. Try to run it for naive matching. Yeah, it returned the offset number 2 here. So it's correct one. But instead of writing the full while for loop like that, we in Python we can implement this function in another way. Let's say short version 2 here, and then we have a button and we have a test. All right. So it's exactly the same for the other region. So just let's change the inside while loop, the nested while loop here. So instead of doing this one, I'm gonna change a little bit. So we have if the test. So from the offset here, yeah, we get the substring inside the test from the offset to the offset plus b length, yeah. And if they equal to the pattern, yeah, so we return the offset here. All right, so let's check it. All right, no, sorry, I need to call this function again. Let's call the version true here, and then we try to scale it. Yeah, it still return exactly the correct answer. All right. And for the time complexity, you know that time complexity a little bit complicated. So for time complexity, so we have a true for loop here. So the performance will be the first one equals to O n minus m, and then inside the nested loop will be O m. So finally, we have a time complexity for the worst case. Will be O m multiply n minus m. Yeah, that's it. But you know that for the best case, so for example, if you are searching English and you want to search that I am easy to test the sentence, so I am a software engineer. And a pattern PP will be let's say school. But you see that usually in English, the word they are usually different in the first or the second characters. So you see that I here they are different in the first character, M also different in the first one, S here they are exactly the same for the first one, but they're different in the second one. All right. So for example, you want to shut another word, let's say wood. For example, so they are exactly different in the first character. So it means that the nested loop the next loop here will be just run for one comparison. So we can call it constant. So for the best case here, for example, for English, the time complexity can be n minus m. So it depends on your context and on your application. The time complexity can move from the worst to the best case. So in some special scenario, even though very complicated algorithm, for example KMB, they just provide the similar performance compared to the naive one. All right. So I will leave the source code inside the video description so you can get it for yourself. And then in the next video, we're going to discuss about how to apply it to challenge some problem in LeetCode website. All right, see you then.